So let's hook up some touch input so we can get some interaction going in our game. In our game class, we are extending Surface View. Surface View, being part of the view hierarchy, receives a bunch of events that we can listen to. The one we care about is the onTouch event. You can bring that in by doing Alt Insert, go to the overrides, and then bring in onTouch event. There's a bunch of these. You want the one that receives an event object. There are two things really to know about this specific event. One is that it returns a Boolean. If you return true, which we will do, it means that we have consumed this event and no one else gets to see it. If you return false, it means that we didn't consume the event and it will be passed on to some other view that might care to listen. Since we are the only listener and our game will capture all input, I'm happy to return true at all times. The other thing is that motion events comes in form of, let me put it this way, the Android operating system deals with all touch as gestures. We don't care about gestures. Like, the amount of information we get from this motion event type is more than we need. There is the number of fingers currently touching the screen, what fingers those are, where they've been previously, and all we want is it pressed or is it released, right? So we're going to filter the event on the action type. I have written up an article on this because it's more complex than it needs to be, and the details are super uninteresting. But if you search for touch, you will find this article, and we have an explanation for exactly how the filter works. We don't care so much. Actually, here's an implementation we can steal. So let's grab that. It's not entirely accurate, but pretty much so. So we override onTouch event, we receive the motion event, then we have a switch where we get the action from the current event, seeing what it is, and we filter it against the action mask. This provides us with two options. Either the action is up, i.e. a release, or it's down, which means the fingers has been pressed. These we don't need. Well, we need something, to be fair. At this point, we have received an event. We know that it's being pressed or it's being released, so we need to communicate to the game what we want to do in this case. So a thing to be aware of, this is a third thing about touch events in this case, is that the touch events comes from another thread. It's not running in our game thread. It might be the UI thread, I'm not entirely sure. In fact, it should be the UI thread. So let's say it's on the UI thread. Either way, you don't want to do any heavy processing in here. You never want to hold this event up. You never want to hold the UI thread up. And whatever we write or read from here needs to be either synchronized or volatile, or, well, if you're causing a race condition here, make sure that it's a benign race condition is what I'm saying. So our game, of course, runs on a separate thread. What I want to do is just log, say, a Boolean for if we're pressing this button or not. And I'm going to name it, let's make it volatile, come on, volatile Boolean. And let's just make this a boost. When you're naming a Boolean, try to name them as a question or a Boolean statement so that it reads naturally in if statements. If is boosting, then do something, right? Volatile simply means that the compiler and the optimizer shouldn't try to cache this value. And I'm not sure it's entirely necessary because I am pretty sure that the Java runtime environment will always guarantee atomic updating of Boolean values and other built-in types. So whether the entity reads this value in the middle of an update or not doesn't really matter. It will always be a valid Boolean. And if there is a race condition, it's trivial because it will be sort of, it will be fixed by the next frame. In worst case scenario, we're ruining a frame update in terms of reading this input correctly, but whatever. If we are stretching across thread boundaries, it's good practice to make this value a volatile so that both threads sees the most up-to-date value whenever they check it. Now then, back to our touch event. On action up, I want boosting to be false. And when I'm putting down my fingers, I want it to be true. So now our player can look at this and take some action. If I go to my player, I can throw away this note because that's in my way. In my update, I want to check, let's see. First of all, let's declare some gameplay variables, because we're gonna want some motion in here now, and those are settings we should probably have. Let's start with acceleration, for example, and maybe a minimum and a maximum velocity, so the ship can't move too fast between frames. Remember that we don't have a concept of time, so if we're moving 1,000 pixels per frame, we might just teleport off screen and tunnel through any obstacles. So you kind of always want to cap your values to something reasonable. And thankfully, we wrote a utility for just such a thing. We have a clamp, so clamping values will be easy. So let me think. We want a bunch of values. Private, final, static. Let's make these floats, I think. So for acceleration, I'm just going to make this a percentage value, so something I can multiply the current velocity with every frame that we are boosting. So that way the boost will build up with a geometric curve, sort of. So let's say we call that 1.1. This means to add 10% to whatever value we have in our velocity every frame that we're applying it, right? Let's say I'm gonna make a few of these so we can make a minimum velocity. I'm just gonna put that at 1 for now. And the only reason I'm putting it as 1 is so that I'm not accidentally multiplying with 0 all the time and never building velocity. This is all going to change. Sorry, that's max velocity. All gameplay values are always ripe for change, right? Right now we're just trying to get shit working, and then we can come back and tweak until it becomes fun. If we have acceleration on the x-axis, we probably want some on the y-axis as well. So let's, for example, have gravity. What do I want gravity to be? Let's put that at the same as acceleration for now. And then we do lift to oppose gravity. And, well, to oppose gravity, we want it to be negative gravity and probably more than gravity, so that, to keep things simple, we can apply gravity every frame, and when we're boosting, we can also apply lift and thus counteract gravity. So I'm just gonna call this gravity times 2. Times 2, thank you. And notice it's negative because I want the ship to move upwards when I'm applying it. I hope that makes sense. Finally, if I stop boosting, I need the ship to slow down. So right now we have acceleration. We should add a drag or friction. Since it's a ship, let's call it drag. And we do the opposite here. Instead of doing something slightly bigger than 1, we'll have something slightly smaller than 1. So say your drag might be 0.97. In this case, you are bleeding off 3% of the velocity every frame. Again, completely arbitrary values. You will have to change these and play around with it to see what makes sense. I see I'm using gravity here. That makes sense. So that gives us some gameplay values. This allows us now to update stuff. So in our update, we can do, by default, every frame, velocity x times equal drag. So we're applying friction every frame. Same thing with velocity y, but that should be, here's the thing. Because we can have velocity on the y-axis be both negative and positive, working with multiplication becomes a bit painful, so I'm just gonna do plus instead. We'll see how this works out. Again, I'm just winging it. That should give us basic motion, slow down, and fall down. Let me see if gravity is indeed plus. Yes, so it'll move down the screen. Okay. Then, if we are boosting at the moment, we can try to counteract these forces. Let's do vel x times equals acceleration. And velocity y should be plus equals lift. Lift in this case is twice the gravity in the opposite direction. This makes sense. I need to make sure that these values are clamped, but let's see how this runs first, if anything happens at all. And while that compiles, I can check how much time we've wasted. So that's 9 minutes, fair enough. Build, 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 build. Go on. There we go. So we have no ship. Okay. I suspect that I need to clamp these values so I don't know, tunnel. Let's see, there's no limit to how much these things can grow. And remember that our update might trigger a couple of thousand times before we start rendering at the startup of the game. So just to avoid a runaway situation here, let's cap it to something reasonable. That should be, let's see, velocity X, utils clamp, and we want to pass in velocity X and clamp it to minimum velocity and maximum velocity. So the value is always forced to stick between those two values. On the y-axis, however, it needs to be able to go negative. So we're going to do minus max. Sorry, there we go. So from a negative velocity to positive max velocity, basically, so that the ship can move equally fast in either direction, up or down. Then let's try that. All right, well, that's reasonable. And, you know, we can tweak things. So one thing, obviously, we don't want the ship to fly off the screen. I don't think we want it moving on the x-axis at all. So I'm going to lock that position down and stop updating X for the spaceship. Let's see. We can simply do this. Not update X, and I can't use the base class implementation anymore. Moving the integration into the base class was probably premature. The stars use it, but the ship should not. So for now, I'm going to do an ugly thing and just split this behavior out. So now we're only updating the y-axis. We can apply that and see the difference. I thought, is it? Go, go, go. There we go. So it sticks to the side of the screen. But now we have no sense of velocity, clearly, right? So we can apply the ship's velocity in the opposite direction, but on the stars, so that the rest of the world moves around the player. I also don't want the player stuck to the edge of the screen. So I'm going to create another value here for our designer to play around with, and just call that player initial position. That's super long and stupid, so let's just call it starting position. Let's put ourselves, I don't know, 40 pixels from the edge of the screen. And so when we start up, we can set X to the starting position. And at the end of update then, if I want to communicate this value over to my stars, I need to have that available in the game class for now. So what I'm doing here is slightly ugly, but not entirely unreasonable. I'm putting a bunch of values here that are perhaps better suited for an input manager or a controller class, but I'm just going to dump them here for now. Like I said, we do the simplest thing first, and then you can iterate on it later on. So let's call this player speed, set it to a default value. We can go back to our player. At the end of our update, when we're happy with the clamping and everything else, we do game player speed equals velocity X. And then in our stars, at our update, we do velocity X equals negative game player speed. Let's see how that behaves. And we build, we build, we build. It's pretty cool. I think the lift might be a bit too quick, so I might want to cap that a little bit, and probably not I probably want to clamp position instead of wrapping. So I can clamp it to the top of the screen. Actually, let's do that. Let's see if we can work it out. Instead of doing wrap, we do clamp. On my Y position, we do to, let's see, that should be 0, because that's the minimum value I want, and top is stage height minus my own height. So that we remain visible. Apply that. By the way, that little lightning thing, if it's Control F10 or something similar, oh, there we go, yeah, Control F10, applies the changes immediately. So now the ship sticks to the screen. Yeah, that's sweet. So the gameplay-wise, obviously, values can be changed, and I might want to move the ship in slightly. We might even allow it a little bit of movement on the x-axis so that the risk is multiplied. Like, the faster we move, the faster we'll collide with any incoming enemies. But this provides a fair sense of motion. So let's take a break here and see what the next step is in the next video.